So who am I? So I'm an evangelist at Docker. I've been at Docker, and over here is Trisha McKenna. She's a colleague of mine at Docker. I've been at Docker for about a couple of years. I'm an evangelist, so I just basically go around, speak at trade shows, talk to customers, do a lot of content creation, do a lot of meetups and workshops and stuff like this. I came to Docker, immediately before Docker, I was at Puppet. So I've been in the open source space for just coming up on 4 years now. Before that, the vast majority of my career was in sort of proprietary closed source software. Before Puppet, I was at VMware. So my whole world was virtualization for 6 years. And so what I like about containers and Docker is this idea that it sort of marries the problems that Puppet was trying to solve with config management, with the virtualization technology, and those kind of things. They solve a lot of the same problems, and I kind of dig that. Before that, I was at Intel for a bit. I was actually at Intel twice. I spent 6 years at Microsoft. So if you've ever, this is installed Windows XP, right? So if you've ever installed Windows XP, there's some text that is like, Windows XP will perform better, and has these features, right? When you install, I wrote that text. So that's my claim to fame. My other claim to fame is, I was in an earthquake with Bill Gates on stage doing a demo, and that's on YouTube. Once upon a time, I was a sysadmin, years ago. I was a Microsoft Certified Systems Engineer on Windows NT 3.1. So a long time ago. I was a certified Banyan engineer. I don't think there's anybody in here that even knows what Banyan is.
Hey, I already gave you shit about that.
Oh, you did.
That's fine.
Those of us with a little more gray in our beards,
Yeah.
we know what Banyan is. So that's how long that was. But it was I actually did it for a bunch of time. I'm not a developer. I can write shell scripts. I can write Python code, but I've never been a professional developer. I come at Docker from the perspective of a sysadmin, as a person who's looking to operationalize it and looking to sort of, how do I productionalize it and how do I work with it. So in our workshop today, we're going to do a combination of slides and we're going to do a bunch of hands-on, right? And my goal is for it to be, like sort of 1/3 slides, 2/3 hands-on. Each one of you will be provided 5 Azure VMs to go up and actually do the hands-on lab. We're going to do it show and tell style, which means I will do it, and then you will go follow along and do it yourself. If you get ahead of me, you are perfectly reasonable to do that, but I guarantee you there will be something you will miss because you went ahead of me because you like to work fast, which means you're not really reading the instructions, you're just copying and pasting. And someone's going to make a mistake. It's going to happen. So you can do that, but if you choose to do that, just really try to read the instructions very carefully because there's a couple of small things you really have to pay attention to. And I'll call that out. So what we're going to do is we're going to build an EE cluster. Then we're going to deploy a single container application on Linux. And then we're going to talk a little bit about a common use case that we're seeing with a lot of our customers, which is migrating traditional applications. So this idea that you don't need to wait for microservices, nirvana, right? You don't have to wait for cloud native nirvana. You can start today, take existing applications that reside inside of a virtual machine, move them into the container, and start realizing some immediate benefits. And so we'll do that with a very simple IIS web application using a tool called Image to Docker. And then from there, we'll go on and we'll talk about what it takes, and that's a Windows application. Then we're going to go on and we're going to look at Compose and how you compose a multi-service, multi-OS application by deploying a Java-based web front end against a Microsoft SQL Server Windows-based backend. So that's what we're going to do. So for those of you not familiar with Docker Enterprise Edition, that is our commercial product. So Docker there used to be an open source Docker project. There is now an open source Moby project, which feeds into Docker. So if you're familiar with Red Hat, that is sort of like Fedora feeds into RHEL, or OpenShift feeds into OpenShift. That's a pretty bad example, but same sort of thing. So Moby feeds into Docker. Docker has a free community edition, which anybody can just use and deploy. And then we have an enterprise edition, which is made up of a couple of different things. One is certification and support. So certified container offerings from companies like Oracle and Microsoft, with support from Docker and IBM and HP and a bunch of other vendors. Then we have, when you get into the standard and advanced versions of Docker Enterprise Edition, we have integrated application and cluster management. So if you think about How many of you have heard of Kubernetes and OpenShift? Okay, Kubernetes, Docker Swarm, right? It's an underlying orchestration layer. OpenShift, a bunch of technologies that are built on top of Kubernetes to do some work. Docker Enterprise Edition has universal control plane and Docker Trusted Registry, stuff built on top of Swarm to do work. Right? So that's what we'll be looking at today, is that stuff. And then of course we have the Docker runtime. So, as I was mentioning before, so we used to have this product called Docker Data Center. Now we just have confusion. But we've got, so Docker Data Center was Universal Control Plane and Docker Trusted Registry, right? Those are part of Enterprise Edition, Standard, and Advanced, right? So if you buy Standard, you get Docker Universal Control Plane and Docker Trusted Registry. And if you buy Advanced, you get some additional features around security scanning and some advanced security capabilities with Docker Trusted Registry and Docker Universal Control Plane. All of that runs on a supported version of the engine, integrates with what you'd expect it to, right? All the different versions of Linux, Windows. So, cool thing about Windows, Windows Server 2016, you get a free copy, you get a free Docker Enterprise Edition basic license. You have a fully supported version of Docker that ships with Windows. And then all the versions of Linux go along with that. So the architecture, we're going to basically build a very, very simple version of this today. So the first thing is the UCP managers. So these are essentially Swarm managers. A couple of things that make Swarm unique. In Kubernetes and in the old version of Swarm, right? You have this idea of having a key value store sitting out there, etcd or some external key value store that holds the state of your cluster. With Docker, that's integrated into the engine and it's integrated into the node. So there is no external distributed store for information about the cluster. That's all built into the engine and it's all built into the managers when you deploy them. So we're actually going to deploy a single manager. But if you deploy multiple managers, you have the internal distributed store, and then you also have what's called a Raft consensus group. And a Raft consensus group is just, how do I decide which one of these multiple managers is my leader? And it's designed so that you can have multiple levels of failover. So you deploy 3 nodes, you can survive 1 node failing, right? If you deploy 5 nodes, it's 2 or 3 nodes, 7 nodes, like 5, 3, 7, multiple layers of failure. It's not about horizontal scalability, it's about failover. So that's built into Swarm as well through the Raft consensus group. So once you stand up a UCP manager, you need nodes to do work, right? So UCP worker nodes are Swarm worker nodes. And so this is a little bit, you can actually schedule work on managers. So you could say, run an Nginx web server, or run my application middleware, or whatever, in a container, and it can end up on a manager. Best practice is to keep it on the workers, right? So the thing about Swarm is that there is no dedicated role to any one node. A node can be a manager, or a node can be a worker, and I can change it programmatically. I can go up to a node that's a worker today and say promote to manager, and it becomes a manager. So they have dynamic programmatically assigned roles. So you've got your workers down here. That's where the workload gets stored. In Docker Enterprise Edition, your managers have to be Linux, but these workers can be Linux or Windows. So alongside that, you also have this thing called Docker Trusted Registry. And Docker Trusted Registry is where all of your internal images are stored, right? And they're shown here off on the side, which is how you would do it in best practice. You would actually dedicate some nodes to your DTR workers. You'd put a load balancer in front of them. You should actually have a load balancer in front of these UCP managers too, but I don't have it in the diagram. And they would serve up your images. In our example today, we're going to put DTR on our worker node. We're going to have 1 Linux worker, 1 Windows worker. We're going to put DTR on the worker node. You wouldn't do that, but for this lab, that's how we're going to do it. So alongside of all that, right, image storage backend can support S3, blobs, Swift, and local storage. External certificate authority, so everything in a Swarm cluster and an E cluster is TLS encrypted. And so we have our own certificate authority to do that TLS encryption. You can integrate your own CA authority if you want to and replace ours out. We also do certs for the SSL communication between the web GUI and the UCP managers. One thing you'll see in our labs today is you're going to get a bunch of warnings in your web browser about that you have an insecure connection. That's because we're using self-signed certs by default, and you're not going to replace them with known certs. So you'll have to do some funkiness we have to do because of that. You can integrate with things like Sysdig or Splunk or the monitoring solution of your choice, and same with logging. So UCP manager nodes, I think I've talked a lot about this, but basically they give you the web UI, they give you the log aggregation, the monitoring of the services, the monitoring of the cluster state, role-based access control. So I'm not going to spend a lot of time, because we don't have a lot of time to talk about detailed features, but one thing I will highlight is we've totally redone the access control model in the latest version. It is now completely granular. So before we sort of had this like you're an admin, or you're an operator, or you have view only, or you have no access. And there was these sort of predefined roles, which we still have, but we also have about 50 individual operational items that you can do. I can create a network. I can attach to a network. And you can build a custom role that says network, junior network operator, and they can create and detach, or they can detach and attach to a network. So they can assign a container to a network or pull it off a network, but they can't create a network. They can't start and stop services. They can't integrate with the registry, right? All of those things. So we have a very detailed RBAC model where you can take these 50 different things, create these custom roles, and then amalgamate resources into things called collections and get really granular in the way you do that. And you can apply that to nodes in the cluster. So if I've built a big cluster of like 20 servers, I can actually deploy role-based access control to these 5 and say, this is the dev cluster, and only these users or this team or this organization can access these servers. You can't schedule any work, you can't manage anything on here if you're not in the dev group. And this is the test set of clusters, and this is the production set of clusters. So as an operator, I can operate a big cluster, right? One single cluster, but I can do this sort of multi-tenancy where I've got different teams operating in there and know that they're isolated away. So that's a new feature, and that actually is only in advanced. That's only in the advanced version. Docker Trusted Registry. So basically, this is where all of your Docker images get stored internal to your organization, right? So it's the internal version of Docker Hub. The big thing I'm going to highlight here is that it is highly available and redundant, right? So deploy 3 DTR replicas. If one fails, you're still going to stay up. The notary server and the notary signer. So notary is a way for you to verify the identity and the provenance of a Docker image. So you come in, and you can do this with Community Edition, but you have to set everything up yourself. We set it up for you. So what Notary does is it lets you go in and digitally sign something. So you are the central IT group, and you say, here are my Python, my Java, my Apache, my Nginx images that I have built. I have lovingly crafted them. They are patched. They are exactly how I want them to be configured. I have digitally signed them. When your developers pull them down, they can verify that they're the right images because you have signed them. But you can also set permissions. You can set the Docker engine to not run unsigned images. So you can't even run them if they're not signed. So you write your code, you push it back up, right? We can look at those signatures and be like, this is signed by Central IT, so it's a good base image. It was written by one of my developers, so I know it's a good image. I'm going to test it, then I'm going to sign it. Before it rolls into production, I've got all 3 signatures. I've verified all 3 signatures. I know exactly where this application came from. And I can actually build with Docker EE 1706 automated image promotion schemes. So that once these things are signed, I can move them from the test repository into the QA repository, into the production repository automatically. I don't have to do that manually. So that's a new feature as well. All right, so that's what Docker EE and what UCP and DTR are in about 10 minutes or so. All right, so this is what we're going to build. So pay attention to this because this is, it's pretty specific the way it's written in the instructions. So you're going to get 3 Linux VMs and you're going to get 2 Windows VMs. Every VM has the naming convention. In our case, because we're in Orange County, it's OC-operating system-cluster number-A, B, or C, right? So it's either going to be Lin or Win, and then each one of you is going to get your own cluster. So like the one I'm working on is cluster 17. You'll get cluster 12, you'll have cluster 6, whatever. The A nodes are the workstation nodes. They are designed for you to SSH into and do the work. So you're going to like Docker pull there, you're going to Docker build there, you're going to Docker push from there. This is so you don't have to push and pull from your individual laptops, right? I didn't want anybody to have to install Docker for Windows or Docker for Mac if they didn't already have it, right? So we're just going to do it here. And you can build your Linux application over here, you're going to build your Windows application over here. Then, when you build your cluster, your C node, there's only one of those, it's the Linux one, that's your manager, and your B nodes are the UCP worker and the DTR server on the Linux side, and the UCP worker on the Windows side, right? So, we're going to build one manager, two worker nodes, Linux and Windows, and then we're going to have these workstation nodes. So, the reason I bring this up is when people ran through this, sort of tested it internally for me, they were confused why they never did, like why they didn't join these nodes to the cluster straight away. You will never join them in the cluster. I mean, if you want to go out and go rogue, you can join with the cluster if you want, right? There's no reason you can't. You're certainly welcome to do that. It's just not part of the lab. So, for those of you who haven't worked with swarm mode, I wanted to stop real briefly and talk about the concept of services and tasks. Because you're going to deploy a service, but a lot of people don't know what a service is. So a service is the functionality you want to put forward, right? It's a web front end, or it's a database, or it's a message queue, or it's some piece of middleware, right? That's a service. And services are routable, like you route to the service. They can show up in service discovery. If I have a database service and a web service, they can easily find each other through DNS or IPVS. That's all built into Docker Swarm. When you start a service, it's based on a single image. So a lot of you are familiar with Kubernetes, right? So Kubernetes has this idea of the pod, right? And the pod can have 1 to n number of containers in it, right? We don't have that. We have what's called a task. And today, with our version of task, with our pod, which is tasks, it's one container, right? So a service is based on one image. It's based on Apache. But I want to have a very redundant Apache installation, so I'm going to stand up 5 containers behind that. Well, those are 5 tasks. Tasks and containers are synonymous. So if I was to say Docker service update, replicas equals 5, Apache, my Apache, that would say take my Apache service and scale it out to 5 instances. That would create 5 tasks, right? So 1 to n number of tasks go into a service, and 1 to n number of services go into an application. So the hierarchy is a node makes a cluster runs services. Services are made of tasks, and that's kind of how you go up with it, right? An application stack, sorry, I left the stack out, but we'll talk about that later, but the application can have multiple services. So when you see that you're deploying a service, that's what you're doing. You're deploying out a unit of work. Our services that we deploy tonight will only have 1 replica in them, but again, if you would like to figure out how to modify what I'm telling you to do to make it replicate 5 or 6 or 10 instances of your service, feel free to do that. It's not in the lab. So the first app we're going to do is a very, very, very simple, I don't know how much more simpler you can get, Linux tweet app. Basically, it's Nginx where we copy a couple files in. That's what we're going to deploy. So that's the Docker file. So you're gonna clone a repo that has the Docker file in it. You're going to build that. You're going to push it up to the DTR server. Then you're going to go into UCP and you're going to deploy it. I'm going to actually do it. So I think I went through all this with you guys, but got cut off a little bit. A nodes. Oh, so when I created your little slips of paper, explicitly call out what were the internal IP versus the external. I figured most people would understand that 10 addresses were internal, right? So when you get your piece of paper, you're going to get a fully qualified domain name. You're going to get a private IP address and a public IP address. The 52s are public, the 10s are private. I assume most people would know that, but I just want to make sure. All right, so, and then if you've never configured the RDP client on the Mac, this is how you do it. The PC name is the fully qualified domain name of your Windows node. The most funky piece of UI ever is that there is no save button on this UI. You actually click the red X in the corner to save the changes. Like, so, and just trust it, it works. You're not closing down and losing everything, but that's how you configure RDP5. So let's jump into it. I am going to come over here to my repo. So I have the repo right here, and I'll give you a link to that. And I'm going to go ahead and install the UCP manager. And I'm going to cheat and copy and paste. So take this out, put this over here. And so the thing you need to change here is your Linux node. Oh, that is wrong. So it says IP address. Use the domain name. I thought I updated that. And the C node. You're going to get so tired of typing these domain names. And they could be longer, but I don't know how. So we're going to take this, we're going to copy this command. And what we're basically doing is, that's a little bit small, isn't it? How's that? A little better. Universal control plane is bootstrapped with a single container. So the single, and so I'm going to basically run the UCP installer. I'm setting the admin username and password in there. You can write it down if you want, but I'm going to give you a GitHub repo that has all of this in it. Yeah, it'll make it easier for you. I'm going to Control C this over, and we're going to jump into here, and we're going to Control V it. And I'm basically going to install it. I'm going to give it the username and password. I'm telling it that the UCP controller is being installed on that domain name. And I'm going to hit interactive. And this is the part, coming up in here, this is the part where the most mistakes happen. It's going to ask me for subject alternative names, right? And, oh shoot, I screwed that up. Boom. You know what? I totally screwed that up. That is not supposed to be the public address. I wasn't reading. It's the private address. So I almost blew this whole thing from the beginning. So what did I say about people not reading and just copying and pasting? So you're going to get a private IP address, and mine is 10.02.83. 10.0.2.83. So let me try that again. So because you want all of your cluster traffic to go, on that internal network. So we're going to do that. And so what's going to happen is it's going to pull some images, then it's going to ask me for my subject alternative names. It's going to generate the certificate, and it needs to know all the ways in which you can talk to the UCP machine, right? And so sometimes you're going to talk to the UCP machine from the public network, so it needs to know both the public IP address and the public fully qualified domain name for the C node. It's clearly spelled out in the repo, but just make sure you do it. So while this is going, I want to go ahead and get you guys started. So I'm going to hand these out. And then let me put something up on the screen that has, and then we'll flip back when this is ready. So what I would say is start by SSHing into all of these nodes and just get the SSH sessions up and running. And I will give you the GitHub repo and you can get started. Okay, yeah, so that's the subject in this. So it's cut off, so you don't be able to see me left. Okay, cool. Yeah, that's one of the reasons I actually do it on the screen. So there you go. And then this issue over here. Everybody's got one? Groovy. Okay, so this thing has come up and it's asked me for the subject alternative names. It's hard to see it because the screen is kind of cut off. But what you're going to put in here is you're going to put in for the C node the public IP address. And you're going to put in the fully qualified domain name of the C address, which in my case is oc-lin-17-c westus2.cloud@azure.com. Right? So put that in. So for the C node, the public IP and the fully qualified domain, and then it'll basically build the Swarm cluster. So for you guys, where's this at? It's right here. Oh, sorry. This is where you want to go. So it's github.com/MikeGColeman/hybrid-workshop. Change this right there. So github.com/MikeGColeman/hybrid-workshop. I normally print that on the piece of paper, and I forgot for this one. So. Man, I was just starting to dance.
What's the address of the SSH? I mean, one of the links we SSH into is what, Ubuntu?
Yeah, it's Ubuntu 1604. I just want to make sure this address is actually the right one. Because I just slacked it to a bunch of people today, and it was actually the wrong one. Yeah, so if you go here, you'll see that. You scroll down, you'll see this is the lab guide you're going to follow. And so I have just done the first step right here. So I'm now on step 5. So I'm going to come in here. And yeah, so now mine is up and running. Right? So my installation is completed. So I'm going to come over here and I'm going to go into my UCP cluster. HTTPS.
Website one more time.
Yeah, github.com/MikeGColeman/hybrid-workshop. Everybody got that? Oh, sorry, we were taking a picture. I like totally. There you go.
Perfect, thanks, appreciate it.
Yep, no worries. So I'm going to go to HTTPS, lin-o-17 oc-17-c.westus2.cloudapp.azure.com. And it's going to come up, and you're going to get this message because we're using self-site certs. We're going to click Advanced. We're going to proceed. And we're going to log in with that username and password, which is Docker 2017. We're going to sign in, and it's going to ask us to upload a license. There's a link in the GitHub repo. There's one of the steps that tells you where to get your license. So I'll upload my license here from downloads. And you'll end up in the cluster. So the next thing we need to do is we need to add our nodes, right? So we're going to come over here. We're going to click Add a Node. And all we have to do is copy this command right here. Click that little thing there, copy it, move back over, and go to our B node. Paste that in, hit enter, and that's it. That's all it takes to join a node. We come back over here, we can actually go to our Windows B node. Oh, if you were prompted to update your Windows nodes, do not do it. Because I can't guarantee that they won't break if you do. So while Windows is starting up, I'm going to go back over here to my cluster. So if I X out of this, you can see that I've now got my B node here as a worker node coming in. And so come back over here, no. You open a PowerShell window, and you basically type that exact same command, or actually paste that exact same command in there. A couple things here. So we're going to paste this in. We're going to hit enter. When you do this, your Windows node is going to disconnect because it flips the network adapter. It just like resets the network adapter and it disconnects the RDP section. So hit that. And this node is joined as a NERC. This node has been joined as a worker. So if I go back over here, I close out of this. So I now have a Windows node and a Linux node as my workers. That's all it takes. So the cluster is now built. Next thing we're going to do, and again, this is all in the guide, we're going to come down in here and we're going to install DTR. Scroll down. You're going to need, this one there's a lot of typing, right? So, oh, that was the RDP node flipping, like I said. So if I just do that, it'll connect back up. You actually will never go back into that node again, so you can leave it closed. Control C, take that, put this over here in my text editor. Control V. So Linux B node fully, remember, the B node, the worker node, is our DTR server. So this is the fully qualified domain name, oc-lin-17-b.westus2.cloudapp.azure.com. So this is saying at what URL will people access this DTR server, right? And then this is saying, where do I actually want to install it? So UCP is like, which node in the cluster should I use it? So this is the host name for the Linux B node. So you can take that from right here. Command C, and you can paste that right there. And then this is the URL of my UCP manager, my UCP server. So it's https oc-lin-17-c, the C node, westus2, cloud.azure.com. So again, the first one is, what is the URL for my DTR server, which is the full URL of the B node. What's the host name that I'm installing it on, and then what is the UCP server URL, right? And then we're giving it the same username and password. So I come over here, I run this on my B node. Or actually, I can run on my, you can run on either one actually. So I'm going to run this over here, clear this so you can see the top of it, paste it in, and off it goes. And this one takes a little bit more time. Oh. Invalid character and host name. I did something like copy paste. Oh, and you need the :443 here. Well, that was it though. All right, well, you guys go ahead and start working, and I'm going to figure out what happened here, and then I'll get back to the next part.
What did you say the passwords were again?
The passwords are Docker. The username is Docker. The password is Docker 2017. If you look in the GitHub repo to that install command, the username and password are in there, and they're in the repo as well. They're in the instructions. But it's Docker and Docker 2017 with Docker all lowercase, Docker 2017 with a capital D. Oh, this is the problem. So let me see something here. Oh, hey, so be aware of this. There's an error in the repo. When you do the DTR install, there's no trailing backslash. There's no trailing slash after the password. So that's what my error was coming from. So if you copy and paste out of here, put that backslash in. I'll fix it and push it, but that was why I was getting the error. So let me get through this. Control C, over here, Control V. There you go. So now it's installing the DTR server. So this one takes a little bit longer than the UCP server did. So the next thing we're going to do is you only do it because of the self-signed certs. So the Docker engine, when you push and pull against the DTR server, it uses TLS certs to verify the identity of that server. So it says, hey, UCP server or DTR server, give me a certificate. And then it looks at that certificate and goes, I don't know, it either looks at it and says cool, or it says not cool. In our case, it'll say not cool because it doesn't know what the root CA of that certificate is. It doesn't trust the certificate because it's not coming from, Let's Encrypt or D or whoever, right? It's not coming from somebody you trust. So what we have to do, because this is a POC environment, is we have to copy down the root certificate off of the DTR server onto each node so that it has that already in its certificate store and it knows that it's a trusted certificate. So you do not have to do this when you use real certificates. You only do it when you use the self-signed certificates. So when this is finished, we'll do that next step. So you guys build your clusters. If you have any questions, throw your hand up in the air, and then I'll do that next step here in about 30 seconds, 2 minutes. How's it going? The password is capital D CKER 2017. It's in the GitHub repo. Oh yeah, there it is. You're right. You're right. It's not. You're right. Yeah. So I told you guys it was provided to you, and it's not. I need to update the lab guide. But yeah. So lowercase Docker for the username, capital D Docker 2017 for the password. Sorry about that. That is also usually printed on the slips, but all right. Let me, because I want to take care of this right now. Shell. Okay, so where was that at? Yeah, so all right, guys, give me. Boy, I don't want to do that. That does not seem right. All right, so if you reload the guide, the username and password show up now after that SSH part. So I've added them in there. So where it says SSH right here, the username is Docker and the password is Docker 2017. So that's in there now. And I have updated the DTR instructions to have the trailing command I needed. So let me do the next thing real fast. So you have to do this on every one of your nodes. So you have in your home directory a copy certs shell script. You need to do a copy certs sh and give it the fully qualified domain name of the B node. So oc-lin-17-b.west-us2.cloud@azure.com. And to make your life way easier, copy that domain name. And do this on every one of your nodes. It basically is going to download the cert and it's going to restart the Docker engine. So it's just copy search.sh and then Linux vNode. Again, in the guide, just wanted to show it to you, and I'm going to do that on every one of my nodes, and including Windows. In Windows, it's I'll show it to you in a second. So when I said you don't have to go back to this node, I lied. So on the Windows nodes, that script is in the root of the C drive, and it's C:\\/ copy certs.ps1. And you will know if this works because what you need to do is you do a Docker login. And so when you do a Docker, sorry, this is really super small. So you do a Docker login, and you log in with Docker 2017. You'll get a login succeeded. If you don't copy the certs over correctly, you'll get an X509 error. All right. So give me. Yeah, so this one didn't work right. This one didn't actually work, and that's the 509 error. So for some reason, I must have fat fingered something. Yep. If you get a firewall error, check your IP addresses. It's you are either giving it the wrong address or you SSH in the wrong node. So let's see what you did. Yeah. So you're in the A node, right? You should have been in the C node. Not that that matters, just understand that like everything you do is where it tells you to be on C, you're going to be on A. Right? So it's up here, it says SSH into the Linux C node. Linux C node. So anyway, yeah, so go into the C node and then just be very, so what you probably did is you SSH into the C node, or in the A node, you use C node IP addresses. And so then it's like, oh, I don't know what you're doing. So that's what the confusion is. Yep, no worries. Oh, the other thing about this copy certs script is it'll tell you done, but it's not really done. It's just done. It's done installing the certs. It's not done rebooting the Docker daemon. Oh, that's because the daemon's restarting the server. Okay. How are folks doing?
Dale's on the additional.
So where did that come up? Here's why. So this line here, this host address is supposed to be the private IP address of the it's supposed to be the internet address. So so this is supposed to be the node C private IP address, not the node C. Yeah, so switch that out to the 10 address and see if that fixes the problem. I like ones where I can find something I think might be the problem. How are we doing over here?
I don't know why.
So good, you guys got bus driver? Alright, you got the one, yeah, okay. So yeah, but you got a web URL. You got the website up. How are we doing? You got, so are you fully, you have all your nodes in there, or you just would you just get it out? Okay, cool. Yeah, that's some, right? Yeah. You might really want to switch that.
So, this IP address, even though I pulled it from here, should it actually be that, or should it be my node B private IP address?
It should be your, so don't copy and paste the token out of the guide, copy it out of your own UI. So it should be from right there, yeah. That should be the node C private IP.
Oh, this is the node C one.
Yeah, that should be the node C.
Okay.
So we're looking at the join token, and it has that IP address in it. So what the join token is saying two things. Hey, where do I find the swarm manager, which is that private IP address, and then that token is something that you can only get from being on a swarm manager. So it's a way to make sure that you can't just randomly join nodes.
Okay.
You can only join nodes if you have the token. You can only get the token if you have physical access to the server.
Right.
If you've got physical access to the server, or you've got access to the server, then you should be all right. How are we doing?
I'm kind of behind. I normally run at Linux, but my Linux would not connect to the local network, so I just switched to Windows 10, which I know it is.
Oh, okay, but you're getting up and running.
I'm getting there.
Okay, all right. You guys still running phones?
No.
Okay. Oh yeah, getting the node, but you got past that area though, right?
I think I'm about to.
Yeah. Yeah. Yep. Yeah, you are, because it's basically rolling them out. So you're good. You're good. you know, it's really like, it's a really, unforgiving process. Like with all the addresses and stuff, it's like, so the reality is that because we know this is unforgiving, we actually have something called Docker for Azure, where you can actually just go in and like say I want 3 nodes, and it would like stand up for you. But wow, such beautiful light coming through the window, illuminating all the IT people. It's really like, you know,
Very sobering, isn't it?
we're in LA, so it's like, we're losing light, people. Let's get to work.
I'm like copy and pasting.
Yeah.
Yeah, good on that.
Who has all their worker nodes installed? And they've got the cluster built. Okay.
Overachievers.
So you guys are you doing the copy search thing? Are you putting PTR together now?
I'm just getting less.
What's that?
Lots of work.
Are you participating in Build there? Are you a delegate?
No, I just have
What's that?
just got some.
Oh yeah. We've done some work with them.
Oh,
So yeah. I remember we've hosted a couple of technical day events.
Oh, yeah, Dr. Connors.
No. It's a meetup on Founder. Yeah, no problem. All right, guys, we're gonna, in about 9 minutes, we're gonna move on to the next section. Just so we can keep it moving for people. But, you know, I'll stay here till it's done. I'm just gonna demo the next part in about 9 minutes. you're done with the hard part. Everything else after this is easy. Yeah, it's actually not that hard. It's just like all the IP addresses and everything.
Yeah, you gotta sync up, right?
You get it synced up and stuff, and then in a lab environment too, it's like a little bit more difficult.
It's
Like,
basically the whole.
the URLs are like ridiculous.
Right.
Like
Yeah.
ridiculously long, like there's so, and I can't like, if anybody has an idea of how I could easily provide you guys the IP addresses in text form so you can copy and paste, let me know. I haven't figured out a way I could do that aside from like email registration, which doesn't really work. Because I think that's one of the bigger problems too, is like fat fingering the IPs and stuff, like trying to like figure out a way for people to not have to worry about that. I want to basically be able to like have people clone the repo.
Cut and paste from one laptop to another.
Well, if you
It's so
could, if you
simple.
could clone the repo and do like a mail merge clone, where like you replace the right fields with the right IP addresses, that would be like the dopest thing.
So you're step 4, and then it's all I get is the app before password. I got to do this whole thing.
Yeah, so I need to edit that, because I actually, yeah, in that step 4 where it says put the password, I actually added it in. Yeah, so I added that in, and that's why it failed for me, since I made that edit, and then it didn't QA it, so I need to take that out of the guide. Again, thank you for beta testing.
MVP.
Yeah, I just updated that step 4 so it doesn't mention the password. So thank you for that. Ooh, that sign. Don't let the sign. Oh shoot. All right, guys, I'm going to move on here real quick and move through a couple of additional steps. So once you get DTR up and running, you're actually going to navigate to the DTR server, which is the domain name of your Linux B node, OCLin17B in my case. and you're going to log in with Docker and Docker 2017, and you're going to get this UI. What you need to do here is we need to create 2 repositories. They're just like GitHub repos, only they're for images, where we store our images. So I'm going to come in here, I'm going to create one called Linux_tweet app. And then I'm going to create one called Windows_tweet app. And I'm going to click save. And so now you've got in Docker Trusted Registry places for you to push your Docker images. So let's go ahead and build that Linux application. So I'm going to come over here to my A node, my workstation node. And I'm going to clone the repo. And I'm going to change directory into, and I've got that Docker file here that we looked at before, right? So I'm just going to do a Docker build. And this is the step where you need to modify what's in the instructions, right? So you're going to need to supply your own Linux bnode fully qualified domain name. So you can take that from right here. So when you tag the image, right, so you're going to build a Docker image, and when we tag it, we have to tell it where to store the image. And so it's going to go up on the server, right? And remember, we just created that repository up there, so it's under the Docker user, and in that repository we just created, Linux_tweet_app, right? And then we tell it to build from the Docker file in the current directory. So it is the server, right? This is unique to you, the user, Docker, and then that repository we just created. So that's how you tag the image. Oh, I totally screwed it up. I got ahead of myself. No, that works, that works. So we hit enter, and it will build out the image. And then after it's done, it's tagged the image for us. We just need to push that. Let me do this. Docker push. And you can copy that out of the output. And that'll push it up to the DPR server, right? And so when we go back up to Docker Trusted Registry, if I click on View Details here next to Linux Tweet App, and I go in here to Images, there I have it, right? I have that's the image I just pushed. So now I want to run that image. I'm going to go into Control Plane. I'm going to click on Services, and I'm going to create the service. So for the name, I'm going to call it Linux_tweet app. For the image, I'm going to point it to that image that I just pushed up there, right? Now this is where you come in here. So you can use something called constraints to position where your containers run. You can build constraints, all kinds of different constraints. You could say, I want this to only run on a server that has SSD. I want this to only run on a server that's in the Western US. I want this to run on a vSphere VM. So you can label all your resources, and then you can build constraints around that. There are a bunch of built-in labels already. One of those is the operating system that the Docker node is running. So Docker already knows if a node is running Linux or Windows, and it knows this from this parameter node.platform.os. And so what I say here is I say, hey, only put this node, this container, on a node running Linux. The other thing I need to do is I need to tell it how to communicate with it. So my web server runs on port 80, and I'm going to expose it on, I have to look at the documentation on where I tell you guys to do this. We're going to run on port 8088. So I'm going to come in here to Universal Control Plane, and I'm going to run on 8088. Make sure you click confirm here after you do this. And that says any request coming into my system, my cluster on 8088 gets routed to port 80. This is something else that Docker UCP has, Docker Swarm. It has ingress load balancing for Linux nodes. So what that means is any Linux node in the cluster, if I hit it on port 8088, it's going to find the right container to present my web page, even if that node that I visit isn't where the actual application is running. And I'll show you what I mean by that. I don't know why this thing keeps flipping out, but it does. So I'm going to click Create, and this takes a second. So this will turn green here in a second, and then we can go look at the actual application running. So now it's green. So this isn't actually in the lab guide, but if I come over here and I click on the service, I can look right here and see, I can click on this, and it tells me that I can get to my web app by going to Linux node C, right? Which is the manager node. But I should also be able to hit it on node B. Oh, what happened there? That was not cool. Man, this is not going to work. Oh, it did work. So that is ingress load balancing. It doesn't matter if I go to the node that's actually hosting the running service or another node in the cluster, it's going to route me correctly, right? So I can go on node B, or I can go on node C, either one of them, and I get my web page, right? And it's actually only running on node C. I can also go in here and say, inspect resources, containers. And this is the actual container that's actually doing it. Remember we talked about those tasks? This is the swarm task, and it tells me that's running on node C. Again, doing something I probably shouldn't do. This might not work, but let's just see what happens. We'll come in here. I can configure the scheduling. I can scale this up to 2, and that will deploy a second instance of the web app. So give it a second to deploy. So now I have 2 of 2. If I come down, I say, if I come down and inspect it, and I say inspect the resources, the containers, you can see that I have one container running on node B and one container running on node C. I've now scaled this up to 2 instances. I could scale it up to 100 instances, right? Or 1,000 or whatever. But it'll load balance between those 2 nodes to provide that service. So why don't you guys go ahead, create your DTR repositories, deploy the Linux Tweet app, and we'll reconvene in another 15 or 20 minutes to do the next section. I wonder why that was failed. Oh, that might have been. What's that? Yeah, it takes a little bit. And this lab repo, of course, is just out there, so you can share this with your friends or whatever. What's not out there, of course, are 5 VMs, but there is a Terraform script in the directory that if you have Azure, you can run the Terraform script. So you don't have to put in your own Azure credentials. I hope my credentials aren't in there. Because, oh boy. So I'm sitting there before, you guys should work, but I'm going to tell you the story anyway, so listen if you feel like you can afford to listen. So it's the day that DockerCon is going to open, and one of the things I do at DockerCon is I oversee the building of all the hands-on labs. And so and the demos on the show floor. and I get a Slack message from someone that says, your AWS credentials should probably not be in a public repo. I break out in a cold sweat, right? We're at dinner, I literally shove my plate of food across the table, whip out my laptop, and I go out and I of course update the repo, push a change, go up to AWS, regenerate the credentials, right? And then I'm like, okay, cool. And then I'm like sitting there and I'm eating, I'm like, oh my, but they're in the history. They're in the history. So I'm like, how do you flatten a repo? And like, I Google it, because I'm not a GitHub expert, because I'm not a developer. And it's like, flattening a repo is not easy. Like, there's like some nonsense you have to do. So I'm like, I know how to flatten a repo the way I fix every GitHub problem, which is what? Delete the repo. So I delete the repo up on GitHub. But somehow, I also delete the local copy. So I've now deleted the local copy, and I've deleted the repo remotely. But because multiple people were working on the project, I called the guy that was doing it, like, Justin, I go, you have that repo? He's like, yeah, but you need to zip that entire repo up, and you need to like put it in a Google Drive for me so I can recreate the repo. So I recreate the repo, everything's fine. But does anybody see what I realized 2 hours later? What did I realize 2 hours later?
You have to go update all your other tools.
No, what I realized 2 hours later was it didn't matter that the AWS credentials were in the history because I had deleted them and changed them. They didn't matter. So I actually deleted all the repos for no reason. Like I totally that whole second half of the crisis didn't even need to happen. Anyway.
Yeah, maybe something we do a phase one.
So now I'm gonna go check the repo and make sure my credentials are in there.
Yeah, I get the impression. Because one of the things I always done is
No credentials. Yeah, so in the workshop directory, there is this provision VMs, and there's a Terraform script in here for, and some instructions on how to use it for Azure. But you need to have your own set of credentials, of course, not mine.
one of the things I was going through that was showing how set up
I thought those Windows machines were common. I started using I had Windows machines as well.
Yeah.
And I started using it, and I'm like,
I use it all the time.
I really like this. My wife yesterday walked up to a picture. Was it? Yeah, no, then I go to my Mac and I'm like, it doesn't work. We were somewhere yesterday, there was like a photograph on the wall next to it, and my wife walked up to the photograph and she was she's like, oh no.
Yeah,
Oh no.
So they like kind of do your website. So they use the best way to control.
fine.
Okay,
Yeah,
because
cool.
this is the Linux app.
Yeah, this one actually takes a little bit, so it's gonna be jumping. It takes a few minutes to do.
Okay.
Yeah, I'll talk a little bit more about finished graphic does and some of what it doesn't do. But yeah, jump.
Okay.
And did you get, so you got the cross off and running?
Yep.
Push and pull, did you get? Sweet, nice, good deal, good deal. Like I said, first time I've done it, so that's what a couple typos, yeah. Glad to see that's working. Yeah, it's running pretty smooth. Yeah, that's the goal, is part of these, it's not that.
Yeah, it's the most frustrating thing I can get is online. Running out there.
Yeah. Yeah, exactly, right? Exactly. Yeah, part of it is just getting people with their hands on it. So, moving to something that's really making answer questions. And we can, of course, answer questions, like, because we're like doing this much, right? We can answer questions on other stuff. I'm also trying to like gauge, because I know that having led a bunch of UCT labs, the install process is pretty people up because it's like those SAMs and copying that data addresses and getting that. It's not difficult, but it's like one letter and you're like, oh, I just got my install started.
Yeah.
No, I wasn't there.
Yeah, I would really, we wrestled with it because the self-site search thing is kind of a pain. So I thought, well, I'm just going to build a big cluster and get rid of the accounts. But then you go worry about port contention. Like, we're all trying to start something on port 8088. That doesn't work, right? So, and there was something else that didn't, we'll talk about it. We'll talk about when we do the Windows node. We'll talk a little bit about the difference between what we did with Linux and what we do with Windows and why we have to do it that way. Because there's a limitation in Windows right now around, we don't have that dangerous load balancing feature. So that was going to become problematic. It's easy with Linux. Like with Linux, I don't have to give it a published port. I can just let it pick one, and it works. And you can do that with Windows, but there's a lot more that goes into like figuring out where it landed. And I was just like, we're not gonna mess with that. We're not gonna mess with that. All right, I think we are at the appointed time to move into the next section. Actually, at least one person has kind of moved in there. I want to talk a little bit about, and if you don't want to hear the slides, then you can keep working, but I'm going to present a couple more slides here. I'm talking about migrating traditional applications, because is what we're going to do. So this is a little bit marketing, but it's also relevant, and I really wish I knew why this thing suddenly started cutting out on me, but please bear with it. So there's a study that was done that says 80% of IT budgets go towards keeping the lights on. So your IT budget, 80% of it is just how do I do the things that I need to do every day? And a big chunk of that is how do I deal with legacy applications, right? Like I did a talk at DockerCon, and I asked a guy, and I said to him, I'll do it here. Raise your hand if you have a system in your environment today that's been running continuously for more than 1 year. 2 years, 3 years, 5 years, 10 years, 15. This guy had a system that was running for 17 years. He was the winner in my session, right? And so you've got this stuff that's like, how many of you are supporting in production Windows Server 2003, Windows Server 2008, Windows Server 2012, right? All these old versions. That costs money. 2008 is out of support, so you're writing a huge check to Microsoft if you need support on that application. To be able to drive innovation, you have to find a way to cut some of that budget out. So we do this program called Migrating Traditional Applications. We work with a bunch of different companies, and one of them was MetLife. And we basically went to them and we said, hey, let's take your old application, and the screen is a little bit messed up, but it's an old Java application. And they said, look, we want to drive down the cost, we want to move to a common governance model and a common deployment model, right? And self-service. So when you put things in a Docker container, if it's Linux or if it's Windows, it's still Docker run. It's still universal control plane. It's still the same API. It's still the same CLI. It's still the same image scanning. All of those things remain constant. So with MetLife, they went in and they went from a 7-day deployment cycle to 5 minutes. Right? They went from 4 servers to 2 servers. Because VMs, they went to bare metal, I believe. Containers are typically more efficient than virtual machines, and they were able to cut out half of their hardware. Right? They were also able to reduce the number of OSs they had to manage. Security patches down from 7 days to 2 hours. That is 6 days and 22 hours that they weren't exposed. Right? That's a huge, huge deal for them. And then they could scale up a service in 5 minutes instead of 7 days. So what is that, so this is what we just talked about. So what is it, what do we talk about legacy apps, right? Why can you get these sort of improvements out of there? Well, because a lot of it is that there's just, how many of you when you go to update a legacy app, do it with a high degree of confidence that something isn't going to break? How many of you basically schedule it for 3 a.m. on a Saturday, right? Because you were like, this is the only time that So there's a lot of lost knowledge. The fixes that go in are not necessarily high quality. You can't really scale them, right? You can't really scale them up and scale them down. And you're kind of like, all right, well, let's hope it works. How many of you have read, I love asking questions, obviously. How many of you read the Phoenix Project? This is full-on Phoenix Project plan, right? Phoenix Project, for those of you who haven't read it, is a story of an auto parts vendor who is competing in the new world of the internet, and they have this project that they're trying to deploy, and everything's a huge mess. And it's how you use DevOps to kind of get through it. It's interesting because you would hear me describe that book, and you would say, that sounds like the worst book ever written. And it's actually really pretty good. It's actually a pretty well-written book. But so, when you talk about LAMP stack and Java applications, or .NET, or .NET IIS applications, these are good legacy applications where you can go out and target. So, what we're basically looking at is this sort of very early stage where you just take an existing application, you move it from a VM into a container, and you roll it out onto modern infrastructure. When people ask me, they're like, well, they'll be like, we have a cloud initiative. We got to get through that before we look at Dockers. And I'm like, looking at containers, I'm like, you are completely backwards. You are backwards. You should start with Docker. And not because I work for them, because it makes sense. If you put that container, if you put that app in a container, then you can easily move it to the cloud. And guess what? Sometimes the cloud isn't what you thought it was going to be. And you want to move it back into a VM, or you want to move it back to onto bare metal. You can transition through those environments, that modern infrastructure, wherever you want it to be very easily once it gets into a container, right? So I always say, like, it starts with Docker. That's where you need to start. So by simply taking existing applications, converting them, and it's just that easy, right? You just say, I'm going to convert you, and it works. No, I mean, it takes, this is, it can take weeks to get through this middle step, but this middle step happens without ever touching the code. It's really just about how you package and deploy the application. And so we have programs out there with solution provider partners, and I recommend if you are an IT person in the room, you're not a partner, I would say go find a partner that has done this. You are going to have your highest degree of success by partnering early on, getting that knowledge, getting that expertise, and then sort of moving onto your own after you've done a couple with somebody who has the experience. Because there are pitfalls, right? So why do this with Docker? Mostly because we don't care if you're Linux or Windows or mainframe. We don't care what your cloud provider is. It doesn't matter to us. And that's why I say it starts with Docker, right? Microservices, ISV, traditional homegrown apps, we'll cover all of it. If you look at other platforms, right? If you say, well, I want to do this with Amazon ECS. That's great if you never want to leave Amazon. Because ECS uses proprietary APIs, they use proprietary formats, right? Or you could say, well, I want to go with something that's, more, like for instance, I want to go with OpenShift. All right, well, you can go with OpenShift. I know they made an announcement today around Windows, but I don't know if Red Hat's ever going to treat Windows like a first class citizen, who knows? But they're sort of locked into that, into Red Hat. That's their business, that's where they make money. We don't make money, we don't make any more money if you're on AWS or if you're on Azure. Right? We don't make any more money if you're on Windows, if you're on IBM Z series mainframes. We don't care, right? That's why why we feel like we're in a good position here. So this is what we're going to do in the lab. Is we're going to do these first 3 steps. So let's get into that. Before we do, this is, please understand, this is a demo. This is the world's simplest application. It's not even an application, it's a static website. So you are not going to leave here and grab your Windows 2003, .NET 2.5 IIS web app and convert it in 5 minutes and have it running. Super simple IIS website. It's running, it was inside of a VM, so we've copied the VHD down. We're going to crack that VHD open with something called image to Docker. Image to Docker can work against Windows Server roles and features. It can look at things that you've used via admin programs. It can look at your domain name server, your IIS server, and your Apache web server. So that's what it can look at. So if you've installed great googly moogly application, we don't know anything about that, right? Unless it came through admin programs, right? So it's not a panacea for everything. It's a tool that can work with a few things, kind of get you going. So that's what we're going to do. We're basically just going to take this Windows Tweet app, which is an IIS web server, and we're going to take the VHD, we're going to run it through image to Docker, and we're going to get basically this Docker file out of it. So let's get that started. So come over here, because I can never remember the command to do this. Go into the hybrid workshop, slide down. All right, so this is the convert to Docker file command. So we're going to take that. We're going to go over to our Windows machine. So if I do a dir c://ws star, that is the Windows Server 2016 VHD. So I'm going to run this against that. I got to copy it again. And we hit enter, and this takes a little bit of time. So I'll let this run and we'll jump back into it in a second. But basically what it's doing, it's mounting the VHD, it's reading it, it's analyzing the contents. From that it builds a Docker file. And then from that we can build and push an image. I'm actually going to do I'm going to do the last 2 demos. That way if you have to leave, because I know that we had about an 8 o'clock finish time, I'll stick around. But if you have to leave, you can leave and still see how everything turns out. So, matter of fact, I'm going to do that while this is running. So, the other thing we're going to do, I don't think I have any slides on that. So, the last thing we're going to do is we're going to deploy a multi-service application. And we're going to do that from this Docker file. So, a Docker file basically allows you to sort of define your application in one file. So if you didn't have this Docker file, you would go out there and you would create a network, and then you would build this service and attach it to that network, and then you would build this service and attach it to that network. And so what we're doing here is we're going to create a network called @C. We're going to build 2 services. The first one is a database, Microsoft SQL Server. And we're going to open up port 1433. Now you see this thing here. There's no Ingress load balancing in Windows today. That thing I talked about, hey, we can go to node B, node C, and we just find it. We don't have that with Windows today. With Windows, you can only use DNS round robin, and so you have to tell it to deploy in host mode. That basically says, put this on one host, and we'll use DNS to find it. So that's why this is different than what you've seen before. And we're going to use a constraint down here to say run this on Windows. Then here we're just going to publish the web app, just like we had before. We're going to say, hey, run this on Linux. So I can take this, and what we're going to get is 2 services and a network. And if I go back into my UCP server, actually here, and I say, I want to, let's clear this out, I want to create a stack. A stack is an application. So I come in here, I give it a name, I say I want to deploy services, and show me all the output. I paste in my compose file, so deploy my database, deploy my web front end, expose port 8080 to port 80, put that on a Linux node and create a network. I hit create, it's going to go out, and it's going to deploy those 3 services, or the network and those 2 services. Okay, I know exactly what I did, so we'll go back to edit. And I forgot the first line of the compose file. So that's easy to fix. I didn't get that right there. So come back over here, put that down, paste that in, return, that, and create. That's the beauty of live demos. So now we'll come in, it will create the network, it'll create the database, it'll create the app server. It'll take a second for those to come up, so let's come back over here. So I have gotten my Docker file. So the output path that we used here was Windows Tweet App. So I'm going to change into that directory. Man, I wish you did it more like Linux. Oh, that's not going to work. And there's the Docker file that we talked about. So now what we're going to do is we're going to do a Docker build. Actually, let's do this. Docker build. And we have to do that again. So it's oc-lin-17-b-west.us2.cloud@azure.com/docker/windows tweet app. Again, that is the repository on my DTR server, and I'm going to hit enter here, and that's going to build my Windows application. This takes a little bit of time to finish. That's why I'm doing these two things simultaneously. So hopefully I'm not making it too difficult to follow. All right, so this is done. It's deployed. We click done. We have this stack here, and we'll come in here and look at the @c app, and we can import the services. And there, the app server's up. The database is still starting. The database takes about 5 minutes to start. You will know when your application is working correctly because when both components are up and running, this box won't be black. It's black right now because it can't connect to the database because that's where all the images are. So that's how you know the difference between a fully functional and a non-functional application. So give this a couple minutes to do its thing. Why don't you guys go ahead and work some more, and then we'll pick this back up whenever this is done.
Just in general, what are the differences in the enterprise version versus
The basic?
Right.
So the basic image, all you get with basic is the command line stuff. So you get swarm mode, but you don't get UCP, you don't get DTR, so that's the big difference. But you get support. And so our support offerings range from 5x8 to 24/7, 365. We have support instances in different countries, so we can do around-the-clock support. We also offer support through, Trisha can keep me honest here, HPE, IBM, and Microsoft. And Cisco. So we have partner relationship with those vendors to provide support for Docker as well. They resell it and support it. So they'll do like the tier 1, we'll do the tier 2 or beyond, depending on the relationship. So that's the big difference. The big difference is any of the GUI stuff we're doing today, you don't get any of that. So everything I've done here, you can do from the command line. It's just not nearly as nice. And there's a bunch of stuff that you can't do: security scanning, image signing. That stuff's all integrated into the advanced and standard versions.
Yeah, I know I have a QNAP NAS that has some of the GUI stuff in it. But
What's that?
I have a QNAP network server that has some of the GUI stuff in it. But I'm not sure how much.
Yeah, I don't know. I haven't looked at one of those. I am uncertain.
Quick question for you.
Yep. I'm sure I have like a long-winded answer with the story to go with it.
That's entertaining. So I built this guy. There's no errors, but he's not. I don't know what 0 or 1 is.
So 0 or 1, that's good. So what's your name?
Troy.
Troy just said, hey, I've got this thing and I've got 0 or 1. I don't know what that means. What that 0 or 1 is, it says the desired state of this service is to have 1 task running. Right now I have 0.
Okay.
Right? And so this just takes a while. Oh, there's this one. So the Windows Tweet app takes about 5 minutes to deploy. And here's why. Here's the dirty little secret about Windows images. They're freaking huge. Like the Windows Server Core image is 10 gigabytes. So So they take a few minutes, because what has to happen is, it has to pull that image down and execute it, right? So it takes a little bit for it to start.
That makes sense.
Yeah. So there we go. So I've got my Windows image built. So we're going to grab that name, and we're going to Control C that, and then we're going to Docker push. We're going to Control V that. We're going to push that up. So just for giggles, after this is done. So you can see these two layers alone are 500 megs that it's pushing. Push that out. There we go. You can do it. It's the other reason we do this on Azure. Can you imagine all of us sitting in this room trying to push like multi-gig images? That would be terrible. So if I clear this and I do a Docker images, you can see the size of these, right? 10 gigs.
Yeah.
The nice thing is that the way Docker images are constructed, we use this concept of layers. And so if all of these are built from Windows Server Core, we only put that first 10 gigs on the system one time, right? Because they're all using that same base image. Then we layer on top of it. So like that IIS image isn't 10 gigs and the Windows Server Core image is 10 gigs, right? It's 10 gigs for the Windows Server Core, and then IIS has like another 100 megs or whatever. Okay, so we've got that up there. Let's go ahead and deploy this Windows service. So we'll come back over to services. We'll create the service. We'll give it a name. Windows Tweet app, and we'll paste in that image. And then a couple of things, scheduling, right? Got to add that constraint, just like we saw in the Docker compose file, node.platform.os equals Windows, and then the network. Now this is where it's different. So hopefully if you jumped ahead, hopefully you paid attention. This has to be set to DNS round robin because again, we don't have that ingress load balancing. And when we publish the port, we have to put it in host mode. And I have to look here because I always get confused on which ports I'm supposed to use. 8082. So I'm going to come over here and I'm going to tell it use port 80, but publish it on port 8082. Click confirm. So this should be host mode as opposed to ingress, and this should be DNS round robin as opposed to virtual IP. And then we hit create, and that will roll out the service. So clear this filter off. So that'll start. Okay, notice my database and my app server are both running. So when I come back to my Enterprise Art website, when I hit refresh, you will see the images pop up because they are now being pulled from the database. So that's the Linux Java front end communicating with the Windows Microsoft SQL Server running on Windows. And that's how we know that it's actually working, is because we have the information on the pieces of art and the motivational portraits that you can actually go buy. So with that, that is the last part of the demo. So work through the rest of it. Topics beyond what's in the. If you have questions about how other more advanced things work, I'm happy to tell you that I can get you in touch with somebody that knows that stuff. If you have those questions. So did your Windows app actually come up?
Oh yeah.
Nice. Yeah, you paid attention to the node and the whatever part.
Yeah. Well, I messed it up and then before.
You go back and
I
do
got
that.
3 errors. I was like, oh yeah, I should read the directions.
Yeah, there you go. Yeah. Did you get one saying you can't do an ingress with a?
Yes, that's the one I did do.
Yeah. You get. That's the one. Yes, sir. So that ends up being a function of your cloud contract, right? So you could, what you can do is, like, sorry, you guys AWS? Yeah. So what you can do is you can build an Omni that's a manager Omni, and put the user data in there that's specific, like, so your worker knows. You build a worker image, and the user data for that worker image is basically how I join the storm cluster. And so as your autoscale trips off, it just adds more workers for you, right? And then once they're joined the cluster, UCP will automatically start scaling